This semester in the Physics 1 mechanics class, you will discuss many of the motions similar to this car moving along a road, maybe a ball rolling along a path, could be an incline, upward, downward, so many options. Whenever we go to describe the motions of these objects, one of the questions come into mind. What are the quantities we need to describe these motions? And throughout the semester, you will encounter, you will need just the quantities we call the scalars, like the car traveled 10 meters, or it took 10 seconds for this car to travel 10 meters. So just the quantities, scalars, or some quantities with a direction. As an example, the velocity of the car was 30 meters per second towards north. We call these as vector quantities, magnitude with direction. Oftentimes, we use an arrow to represent vector quantities. First, we start with the one-dimension, 1D vector quantities. And as you can see right here, we have the horizontal axis, positive direction x or negative x direction from the origin. It could be up and down on a vertical y-axis. Here we have one-dimension vector with an arrow, vector A. Also, you will encounter two-dimension vectors, not only just x, not only just y-axis. In here, we have both x-axis and y-axis. Here we use another arrow to represent our vector A. And oftentimes, you will see there will be an angle, could be theta, could be pi, any angle specified. Sometimes it's the x-axis, horizontal axis specified angle theta, or sometimes it could be specified from the y-axis. And in these times, two-dimension vector quantities, we should be able to, from this representation, to go to the other representations to talk about how big is the x component of the vector A, how big is the y component of the vector A x component along the x direction, a y component along the y direction. So in this video, we have one of the examples. This car is rolling along the road, and oftentimes we talk about the velocity. We represent it using an arrow, velocity vector v. And we will have the horizontal axis x and vertical axis y. And the idea is here to describe the x component of the velocity vx in terms of meters per second, y component of the velocity in terms of meters per second. And if we have the angle theta specified in our vector representation, as you can see from above, it is clear. If I have the velocity vector v, if the given angle theta is right here, theta, if you curl your fingers, if you take your forefingers in your left hand and you point it towards the velocity vector, curve it towards the angle, you will go towards the x direction. Your forefingers will be pointing towards the x direction. X component of the velocity, v times velocity times cosine of the given angle, cosine theta. X component of the velocity, v times cosine theta. And to get the y component, again, forefingers in your left hand and go the y direction away from the angle. You will find y component of the velocity, v times sine angle, v times sine theta. Towards the direction of the angle, v cosine theta. Away from the angle, v sine theta.